Given a word list, we want to implement a spell checker that converts a query word into a correct word. For a given query word, the spell checker handles two categories of spelling mistakes. There's going to be capitalization, and then there's going to be vowel errors. If the query matches a word in the word list, so that would be like one of these right here for this example, it's case insensitive, then the query word is returned with the same case as the case in the word list. So looking at our code right here, I'm going to run through it with the intention of a debug here. And then we can see all of the happenings of this code, what's really going on here. And that breakpoint should start right here. So we can start skipping through this. We have our word list, which is a hash set. And we're just going to add all of these into our hash set so that we get some good runtime. So adding all of these in, we can see that's our hash set. We also have our queries 1, and this is our queries. So this word list is going to be basically a little database full of words that these queries can access. And if we want to test different cases, we can just replace our queries 1 with queries 2. We can clear our word list and put a different word list in there. And then we also have like this test right here. So we have queries 1 and queries right here. These both use the same words list, but this one would use like a different words list. So that's just to note. And this code will be in a Google Docs in the description below the like button. So now through here, we are going to come down to our vowel portion. So remember we said we have capitalization and we have vowels. Well, for our vowels, we're going to make a hash set. And in this hash set, we have A, E, I, O, U, and those are all of our values. Now, we have an array list to also store our answer. This Boolean run, I've coded this, but probably coded it after doing a lot of this code, so we'll come back to this later. And same thing for this int counter, but we have a description of this right here. So if this doesn't make sense, it will make more sense later. But it's so that we don't output just like a blank space in the last iteration. Since when this output runs, it's basically a loop to check, and another loop to check. And then at the very end, we have this if statement to print this out. Without this if statement, we would just print this out every single time if it doesn't encounter a break. And so we don't just want to do that on the very last one. That wouldn't be ideal if we have like an else case right here. We don't really want that. So that is something just to consider. We're not an else case, just if we're done, it would fall through here and it would print this out on the next one. So coming back up here, we have our array list, it's false, our header int, and then we have this for loop. Now this for loop is like our outermost loop. It's going to run through our entire query. So everything that's passed in right here. Now this for loop is a for each loop. So we have a array list and we're just making a string right here that's going to run through the entire thing. And then we're going to increment our counter to end everything every single time that this runs, so we know that when we're done. Now, for better coding practice, it would probably be great to put this in its own method and just pass in this word set, this word list, this hash set, and this string queries. That is the most ideal, so you could improve that right there. Another improvement could be this if statement. So we have an if statement right here, and then we have an if statement right here. Now, this if statement checks to see if our word list dot contains our current string from the query. So word list, remember, it's the hash set. So we're going to check everything. We're going to compare it to our current. If that's true, we're just going to add it inside of here. Otherwise, we're going to go into this else, and this else is all of this down here. That's what all this else is. So we could possibly combine these two together, possibly do like an ignore case. And I think there is a reason why I didn't do that, but this is just going to run, and then we're in this for loop. Now this for loop is again a for each loop, so it's going to take the string current it, and our current it should probably, it's just going to be another int, just like this string current right here, string CUR. So we are just basically making another for each loop, and we're running it through our word list. And our word list, remember, is our hash set. So what we're going to be doing here is the case insensitive. We are going to run through our entire hash set, and we're going to say if the current hash set, so current dot equals ignore case, so the current string from our hash set. If we get this current string from inside of our word list, if this is equal to true, so if it's true, if it equals to ignore case to the current, and current is the one we're looking at right here. It's a lot of current one, but current CUR is the one for the queries. Also, a better improvement would be the naming, but CUR is for queries. Current it is the one for our word list. So we have current it dot equals ignore case CUR, and so we're passing this in, and this is iterating through our word list. Once we hit the first insensitive case, we're going to want to break, and this is just for better runtime. We could run through this entire thing, but for better runtime, we don't want to do that. So if this equals to each other, if we're ignoring the case and they equal to each other, we just want to add this into our answer array, and we're going to have little quotes around it. So we have quotes, and then we're just adding this in, and then we are going to return, or we're going to run is set run equal to true, and this has to do with our Boolean value right here. So we have run is equal to false, but then we're going to set run equal to true right here. And when run is equal to true, we then increment our counter to end everything. And then after this, we are going to break. I actually don't think we need the counter to end everything right here. So we can just comment it out for now and see if it breaks our code later. And we should probably leave it in there just for the debug for now. But it's going to, if we set the debug, it's going to go through here. Run is set to false. Or run is false currently, and it's going to set run to true through this line. Counter to end everything is now 3, and then we break. So this might have to be in here, but we'll see if we comment it out. We have this break. Otherwise, if we go through this, we're going to set our else run equals to false, because we shouldn't fall through this else statement because of this break. So otherwise it's going to equal to false. And then this probably doesn't have to be an else statement, it could just be outside of here. But after that, we're going to say if not run. So basically if run is false, we're going to be inside of here. If run is false, like I was saying, we should have hit this break statement if it were true. So if it's not true, we're going to set our run to false, and that means we're going to be inside of here. If we are in this if statement, run is true, and then we could just break out of here, totally skip over, and go back to this right here. But inside of here, if our run is not true, we are going to make a string builder to store a vowelless word. So here's how I'm going to handle the vowel errors, and this is what it's asking for us. If after replacing the vowels A, E, I, O, U of the query word with any vowel individually, it matches a word in the word list, case insensitive, then the query word is returned with the same case as the match in the word list. So same case as match in the word list, well, let's just return the word list version of it. And if it's case insensitive, well, let's ignore the case when we compare these. And so I'm just running through my process of thinking. And let's say, since we don't care about the vowel, what if we just replace the vowel with a space? So it's all the same. We just, instead of having a vowel, we have a white space. So then we can compare and see if these are exactly the same, other than the vowel. So that's exactly what I'm going to do. We're storing the vowelless word for our query inside of build right here. So we're going to look through the current element and take out any vowels. This is for our cur.length. Remember, cur is the one that we have on this outside for loop right here. That's the one that's going through our queries. Again, better naming is probably better for this, but we're running this as long as b is less than current.length. B is just some arbitrary value. And then inside of here is the meat. If our vowel.contains current at char b, but this is a not, so this is basically saying if our vowel does not contain current at char b, we're going to build.append our current.char at b to our build. So this is a lot right here, but basically we're calling this string builder class. And with the string builder classes, it allows us to make an instance right here and build a string on it. So we're saying, remember, if it's not a vowel, we don't care about replacing it. So if it's not a vowel, we are going to just put it inside of here. Only if it's a vowel, we're going to put a string here. So if it is not a vowel, so not a vowel dot contains, the current.char at b just gets the current character at our specific current string, and it's going to put this inside of our build. Otherwise, if it is a vowel, we're going to build .append a space right here. And we're going to see this a little bit right here. It's very similar. And this is for our word list. So in the word list, we're going to run through the entire thing, removing vowels of each one and comparing it to it. So if we want to go through our word list, since it's a hash set, we need to use iterator. That's what we're doing right here. We have it1. And then we're going to have string build 1, and it's just set to like this. The reason why we're not using a string builder class right here is just because I want to demonstrate that it could be done like this as well. So we have a while loop that's going to run as long as it1.hasNext. So as long as we have something else in our word list that we can check, we're going to be inside of here. Now, our string save is going to be equal to it1.next, because whenever we do an iterator, we move forward whenever we do .next. So we store it inside of something. So inside of the save is now our whatever value is in our hash set, which is like our word list. So it's one of these right here. Probably start with this one, then this one, then this one, then this one. So it's going to store that inside of save. We're going to run this as long as it's less than save.length, and then we're going to have our b++. So this increments it through the entire time. Now, I've been kind of slacking on the debugging, so let's run through the debugging and see what it looks like. So if run is equal to false, we're going to, or if it's true, we're going to go back up like I was saying, and then we're going to go through here. We added that in. We're going to keep going through here. Now we're going to go back to our for loop. We're going to go into this if statement. We have our else statement. Let's see if this falls in here. Nope, it doesn't fall in there, so we would just keep going. Back up, and then we're just going to print, because that is going to be it for that. So that is how it would print for this one. That's the output for our specific input. Now if we wanted to change this to run something else, I'm going to run our queries1. So I just come down to our for loop, the outer for loop, and this is queries. We're changing this to queries1. And we have to come all the way down here, and we run this as long as we have less than queries1.length. And so let's see if taking it out broke our code. And it looks like taking it out did not break our code. And what I'm referring to is when we took out this counter right here. So I don't think this counter was necessary. We didn't need to have it in here. It works perfectly fine just as it is. And I'm not exactly sure why it didn't break the code, but it does not. So we could just leave it commented out, and we could just say found out not needed. Just in case we have some error in the future, we could look back to that as some kind of possible thing. So looking at our debugger again, I'm going to run it for our main. It's going to run through the entire thing again. It's just setting all of our values, and hopefully we can demonstrate it running through our if statement down there. It should run for this one because there are a lot of unknowns for this. So now we are going to if our run is false, we're inside of here. So pay attention to the current .length build. So the current .length is associated with our string builder build. Our build is currently like null right now. There's nothing in there. But if we keep appending to it, we can see we have an H, we can have a space, we have another space, and then we have R. And that is for here. So with that done, we can now move on to the one from our word list. So we'll skip down here. We have our iterator, we're going through it. We have our string build, and then we're going to go through here. Now notice our build 1, it's just like how build was before, and we need to add into it. So we're going to be inside of this for loop, and we're running this as long as less than save.length. So this is basically looking at the entire current iterated word. So we're going to go through here. If the value is not a character, or if it's not a what's it called, a vowel. If it's not a vowel, we're going to be inside of here, and then we're just going to add this to our build 1. We're going to append it. So we can come down here, we can see it's a K, and then the next one I think should be a space. We can see we have a space here. Click this, we can see we have K and then a space. Keep going, we can see that we have a T, and then if we go one more time, it's not going to match up. So we are going to keep going, and it should break out of here. Once it breaks out, we're in this if statement. So after we've done this, we've gotten our current query element, and then we've compared everything inside of here. Now, this is just comparing inside of this for loop that we've done. After we compare it inside of this for loop, not really comparing. This for loop, I'm sorry, is not comparing. This for loop, what it's doing is like how we were doing here. We were iterating through our current string value, to see if it's the same. We can see it's clearly not the same. We have H space R and then K space T space. So they're not going to be the same. This if statement checks that. It says if build.toString.equals ignore case or build1. So we're comparing the two here. We're going to add our save, which is the it1.next, which is from our query or the word list. It's going to be added to our answer array. However, it's not here. We can see that if we run the debug, it's going to go into this else because this is false. Otherwise, we are just going to add this blank space right here. And that's how we would run it for the first one. At the very end, if our counter to and everything does not equal our queries.length, we're just going to add this here. So I actually mixed these up. This else does not add into our array list. That's what this if statement does. This else is just resetting our build1. So that way when we run through this while loop again, we check our next word list element. So this is checking every single element inside of our hash map and trying to compare it to our current query, to the database. So we can keep going through it, and we can see that is exactly what it does. I'm going a little bit fast just to get the idea of it here, but when it's done, it should fall into that if statement. We saw it quickly go into that if statement. That's where this gets added in, and then it would be the same thing for this process. And then the key one, or the kite, that's the next one after this. It's going to be a little bit different. We can see the actual comparison process. It is pretty cool. So currently our cur is here, this one right here. This we know is going to be a space. So we're just going to do the same thing as we did last time. We're going to keep running through it until we lastly fall into this if, or the last if statement that adds a space. So now is the interesting one. This one, we have our KETI. This is our KETI right here. And if we look inside of here, we should have a KITE, which would be, I think, this first one right here. Now, for this one, if we remove the values, they're the exact same thing. So we're going to see that we fall into our if not run once we get through with this. And this is just iterating through to make sure we don't have any case insensitives. I don't know if I mentioned it earlier, but a better way would be to possibly combine these two. I don't think you can though, unless I might be really tired, but because it has to iterate through here, might not be able to. But because it's just a for loop, I think it is possible. I'm sure it's possible, so that's a good try. Now we have our KETI here. We're going to store just K space T space inside of our build, so we can watch this right here. Our build is K space, and we can see that it's going to add a T, and then it's going to add a space. Now we're going to go into this iterator where we look through our entire hash map that stores our database of possible things. So we have our K space T space. This is in our build 1 after we've run through all of this. So that means when we're in this if else statement, we're going to go into this if statement and we're going to save this into our array list. And that's how that would work. Eventually we would come and we would go into this print line statement. Note how we are not going to execute this. We are not going to add just a space in here because we just don't need to. So we're going to keep going through here, and then we would just keep going. And so that is how we would run this code. That is how we would solve this problem and anything like it.